we're going to be talking about Ethernet switching, and I need you to give me your attention, serious attention, because these are part of the fundamentals, and you can see this one's practically in the class. Please let me know if you can see my screen. Thumbs up. Okay, thank you. Thank you, Mr. Oche. Yeah, I noticed some people are watching my video. You don't like, you don't put, what is it called? Some people have not even subscribed. Please do me a favor if you are enjoying what I'm doing. Share the link to people. You guys, some of you are instructors too. You have students. Somebody is saying they can't hear anything. Can you people hear me? Mr. Okay. Yeah, maybe it's from your hand. You can check your own hand. So share my link for your students. Share it. We have people all over different African countries on this platform. So please share this link for people. And when you go there to watch a video, like the video. If you can make comment, fine. It will really help my channel to grow. All right, so thank you so much, guys. So let's get to the business of the day, Ethernet switching. Anytime you hear Ethernet, you know we're talking about layer 2. We discussed that one before. You are hearing switching. It's all about layer 2. So in today's class, what exactly do we want to learn in today's class? Basically, we want to learn how the switch operates. If you remember when we started this class, introduction, I spoke about repeater when you want to build a network. I spoke about repeater. Then from repeater, they moved to a hub. And I said these two devices are not smart. I'm going to demonstrate that to you. See, hub are not smart, meaning when they get the message, they send to everybody. I say from there, they move to a bridge. And from bridge, they move to switch. And that's where we have today when it comes to building local area network. Of course, we have a router. A router is to build when you have more than one network. So this Ethernet switching we want to talk about in today's class is all about switch. How the switch carry out its operation. What does it really do? How? We'll discuss that at the data link layer. We said for somebody to send message from point A to point B, source MAC address, destination MAC address must be in that message. Source MAC address, destination MAC address must be in that message. That's a layer 2 thing. And guess what again? Okay, let me just draw something. Let's say this is Roland. Then I have a switch. And then this is Uche. I want to message Uche. In my message, before it gets out of my computer here, I will put my source MAC address and its own destination MAC address. When it gets to the switch, how would the switch know where Uche is located? Let's add another person. Let's ask class rep. Let's add Pedro. There are 4 people connected on this switch. How will this switch know where Uche is located? The switch uses what we call a MAC address table. MAC address table, meaning what? It's going to build that table, MAC address table. It's going to build that table. And what will be in that table? It's going to map everybody's port number. Let's say I'm plug on port F0/1. Uche is on, class rep is on F0/2. Uche is on F0/3. Let's say Pedro is on F0/4. You are going to see it. I'm going to show you guys in today's class. It's going to map our MAC addresses to the port. MAC addresses to the port. MAC addresses to the port. So when the message comes in, it will just check the MAC address, destination MAC address precisely, and know that this message belongs to Uche, and then forward the message to Uche. That's the behavior of a switch. So I'm going to show to you why are we using switch now? Why did we run away from hub? These are all the things I'm going to show you. So just follow me. Follow me. So first thing first, I want to show you guys. You need to know how to get the MAC address of your computer out because we are talking about Ethernet switching. Because this is what my computer will use. I will go to my command line. I think I've showed you guys how to go to command line before. Let me do it again. You can right click your system. Go to terminal. That is, I say the system, the start button. Go to terminal. You see terminal here. You can get a command line from there. You can also search for it. You can just type CMD. That's the short word for command line. And click this command prompt up here. You also get your command line. We have some things to do in this environment as we proceed in this training. So what I want to show you guys here, for instance, from here now, I can test for connectivity. Ping, we're going to come and talk about ping in another class, maybe on Friday. Okay, my system is not browsing. I want to see, can I even get out of this system? Can I ping, meaning can I connect to maybe google.com? Google.com, I will say ping. When you say reply form, and that means that ping is successful. That is one of the tools we use at this command line. I'm going to show you guys more things about ping when we come to that place. Now, the one I want to show you, talk about it now is, I want to see the MAC address of this computer that I'm using to browse here. IP config spacebar /all. If you say only IP config, guys, it will only show you IP addresses. Look at them here. I am using my Wi-Fi. Look at, I have IPv6, different IPv6 addresses, and I have IPv4 address. This one I'm particular about now. I want us to pay attention to this one. I have what is called subnet mask. These are all the things we're going to deal with next week in our next class. But there is no MAC address here. So this is the layer 3 address of this computer here. This one here. That's the layer 3 address that this computer got from the router. So what about MAC address? I want to see the MAC address. I can use up arrow key to bring that command back. Then spacebar /all. If I do this and hit enter, you are going to see what is called a physical address. Physical address is the same thing as MAC address. It's the same thing as layer 2 address. And this is the MAC address of my computer. Wireless. Because I only have wireless. I don't have wired. So I want to write this address out because I'm going somewhere. Going somewhere. So this is the MAC address of this computer. If I want to talk to ClassRef right now, this MAC address will be in that layer 2 header as the source MAC address. Take note of that. And this is why I brought you guys here, because we are dealing with Ethernet switching now. Want to see how the switch operates. So how do you get MAC address from a regular computer? This is it. There are other reasons why you may need to know this MAC address. Case in point, maybe I want to block you from my wireless network. I can add this MAC address to my Wi-Fi and block you from there. I will just tell my access point not to allow this MAC address to browse the internet. That is one of the use of this kind of MAC address. But beyond that, it's just for us to know a layer 2 address of a particular computer. I'm going somewhere. So this particular MAC address that I just showed you right now, I want to say something about it before I move to the demonstration. This MAC address, I have, my MAC address is C8 34 8E 49 8E EF. If you take a look at this MAC address now, it is represented in hexadecimal. That's number 2 now, the first thing I want to talk about. Computers do not talk in decimal, you know that one. But there are some figures too, or some numbers too we get. They are not in decimal. When we are dealing with computer, they are not in decimal. They are in hexadecimal. For instance, when we put an IP address on the computer, and I said 192.168.1.1, this is in decimal. But when it comes to MAC address, it is represented in hexadecimal. That's another thing we're going to do next week. I'm going to be teaching about binary conversion from binary to decimal, binary to hexadecimal. So my point is this number you are looking at is 1 hexadecimal digit. If you know a hexadecimal in secondary school, you know it's base 16 from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have A, B, C, D, E, F. This is equivalent to 10. This is equivalent to 11. This is equivalent to 12. Equivalent to 13. Equivalent to 14. Equivalent to 15. So I can pick any combination of any number. Say each of these digits is 4 bits. Any digit you see here is 4 bits. Each of these digits is 4 bits. So your, what do you call it? Your MAC address is a combination of all these numbers. You just pick some numbers. So this is my point. C, if we convert 6 to binary, we're going to get 4 bits. If you convert 8 to binary, we're going to get 4 bits. We're going to do that practically next week. 3 to binary, 4 bits. So if you count all these digits we have here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It therefore means my MAC address is always 12 hexadecimal digits. My MAC address is 12 hexadecimal digits. So what if you now want to convert this to, or want to tell me in terms of binary? You multiply by 4, because you know that each of these digits is 4 bits. That means my MAC address is always 48 bits. Don't forget this. Each digit, each hexadecimal digit is equivalent to 4 bits, 4 zeros and ones. That calculation will do it by next week. So I'm going somewhere here. When you see MAC address, you should understand how it's in hexadecimal. That's number 1. You should know that it's 12 hexadecimal digits. That's number 2. You should be able to tell her that it is 48 bits. That is number 3. And the last part I want to tell you, there is a portion of this MAC address that is called OUI, Organization Unique Identifier. Organization Unique Identifier. And there is another portion that is called vendor assigned. Vendor assigned. So which part is OUI? The first 6 hexadecimal digits. 1, 2, 3, 4, 5, 6. If I cut this from here now, this hexadecimal digit that I have here, this is first 6 hexadecimal digit, is the one that represents the OUI. The other remaining hexadecimal digits here is the one that is vendor assigned. What's the big deal about this? If I am the one manufacturing a particular network card, let's say Cisco, for example, Cisco manufactures network cards too. All the network cards manufactured from Cisco, we have the same OUI portion all over the world. That is what represents this card is from Cisco. Let's say HP also manufactures network card. The first hexadecimal, 6 hexadecimal digits, which is called the OUI, will be the same all over the world in all the computers. But the only part that will be different is the one that is called vendor assigned. So my point is this: whenever you see a MAC address, not an IP address, whenever you see a MAC address, you should know that MAC address, a portion of it is called OUI, Organization Unique Identifier. It represents the manufacturer. Another portion is the one that is unique to that computer itself. That's why if you go to some organization, let's say they bought 50 computers, 100 computers, let's say from the same vendor, maybe HP, you will see that this portion of the MAC addresses of all those systems will be the same. Why? Because they bought or manufactured, the manufacturer of those, the network card on those computers are the same. It's the same manufacturer all over. These are stuffs you need to first of all understand about your MAC address. MAC address is a layer 2 address. It's a physical address. It's called MAC address. It's 48 bits. That's if you're talking binary. It's 12 hexadecimal digit, and you can piece it into 2 portions. One part is OUI, the other one is vendor assigned. And of course, you know it's a layer 2 thing. That is where our frame is built. Frame header, source MAC address is added, destination MAC address is added. You need to know this first. And you need to know how to find the MAC address on the computer. And this is the first thing I want to talk about. I'm going to give room for questions when we get to the question time. I may divide it into 2 sections today, maybe. Let me see. I'm going somewhere, guys. So we've talked about frame before. We've talked about, thank you, Mr. Wichi. We've talked about frame, we've talked about Ethernet, and I've told you Ethernet is a LAN technology, and there are different Ethernet technology. We have Ethernet, we have fast Ethernet, we have gigabit Ethernet, and so on and so forth. I remember I've mentioned all of these things before in the class. So I'm going somewhere with this MAC addressing. This is what I just told you guys. Did I say 46? This thing is 12. No, I think I mean 1, 2, 3, 4, 5, 6. Yes, I'm correct. 46 is the decimal digit. Yeah, represent the OUI. I'm very correct. So I want to show you guys something. This is the bread and butter of today's class. This is called a packet tracer. I'm going to show you guys how to use a packet tracer. As a matter of fact, I have a video on my YouTube channel where I talked about the basis of packet tracer, because those guys I'm teaching, I just showed them or introduced them to packet tracer in that class. So I'm going to teach you guys how to use packet tracer, because from once we start doing configuration, that is what you're going to be working with. This is Cisco simulator that put commands at your fingertips, guys. You don't need to go and buy your physical router or switches or computers to build lab and practice. You can practice with packet tracer. Even though I always recommend my international students, when we're done with training, to build their own lab and tell them where they can get cheap equipment. And that's one of the secrets of the training. Because when you get a job, you're not going to be working with packet tracer in the field. So we're going to get there, guys. So what I want to do here now. Remember, I will say the journey started from a repeater. What's the big deal with the repeater? Repeater regenerates signal strength. Limitation, it has few ports. So the repeater that I saw on this packet tracer has just 2 ports. So I now move to hub. I said they move to a hub. So what's the difference between a hub and a repeater? If you remember that class, a hub has multi-port repeater. So like in this particular design or topology that I have right now, I built a network before this class started. I built a local area network, and I decided to use a hub. See me here, see Uchi, see Pedro, see Faustin. Those are the people I remember when I was building the local area network. I want to show you one of the reasons why we don't use hub again. I mentioned it in that class when I taught you guys, but I need to demonstrate it to you. This was one of the things I was trying to demonstrate in one class like that we couldn't finish. So let me show you something, guys. Let me show you something. I will move to what we call a simulation mode. I want to send a message to Uchi. Uchi has an IP address. I think Uchi's IP address is, let me see, IP config. Okay, 1.2. I want to send a message to Uchi. And I want to simulate this by using a ping command. Ping is to test for connectivity, whether I can see that person. But in real life, it's real data I will be sending, maybe messages and all of that. So now I want to send a message to Uchi. So what will I do? I will go to my computer. I can go to simulation mode first, then go to my computer and send a ping message. Ping 192.168.1.2. That is Uchi's IP address. So I want to ping Uchi, meaning I'm sending data to Uchi. If I hit enter right now, there is going to be a packet or an envelope. If I open this envelope right now, I can click this envelope and open this envelope. There's some information you see there. You see information at layer 1. You see information at layer 2. See information at layer 2 here. See information at layer 3 here. Now look at this layer 2. I like this packet tracer. Source IP address, source MAC address is here. Destination MAC address is there. Let's confirm it. I should have confirmed that. Maybe when we're done. Let me write it down. One ended with 77 DC. The other one is 44 DB. So at layer 2, you can see at layer 2, which is our Ethernet frame header, source MAC address has been added. Destination MAC address has been added. At layer 3, which is our IP header, source IP address has been added, and destination IP address has been added. That is it, the way it works. So you see what is going to happen right now. I want to talk to Uchi. Thank you, Mr. Huma. I want to talk to Uchi. Watch what hub will do. The message will go to the hub. Now look at what hub will do. This message is meant for Uche. Hub will replicate the message and send to everybody. When Uche is replying again, see, when he sent to everybody, Pedro didn't process the information. That's why you are seeing X. Fasting didn't process the information. That's why you are seeing X. They just know are nice guys. Imagine in these days of cyber of security, one hacker is just sitting down there getting free data, free information, free of charge. Now, guess what? Too? When Uche replies back, the Hub will do what he knows how to do best again. The reply will be replicated again and sent to everybody. We're just banking on your magnanimity, they call it now. You being nice, not to harvest our data. That is how stupid a Hub was. If you like, send message 1 million times, guys. It's the same thing that will keep on happening. It's the same thing. Let's try another person on this network. Let's try Frosting. Let's get Frosting's IP address. IP config 192.168.1.4. That is Frosting's IP address. So now if I try to talk to Frosting now, so I'll send a message, I'll send the data. Ping. Here's what? 4, right? 192.168.1.4. I'll hit enter. I've generated the packet to be sent. What is going to happen? The message, if I open that message now, I didn't check his MAC address. Let's check his MAC address. Just check his IP address. So we see what is in that header. See his MAC address here. What is the physical address? It ended with 96 DC. So now, if I open this envelope right now, you see that source MAC address has been added, guys. Look at my MAC address here. Look at Frosting's MAC address here. That's a layer 2. These are layer 3. My IP address. Frosting's IP address. It has been added. I'm going to talk about this ICMP typing when we come to ICMP. So, fine. We have built the packets. We have built everything. Oya Hub, what do you do now? The message gets to the Hub. The guy will do what he knows how to do best. Replicate it, send it to everybody. And when the first thing, you see, Uche is a nice guy. He didn't collect the message. He didn't process it. Pedro is also nice. He did not process it. It meant for Fasting. Fasting will reply back. And then the Hub will do what he knows how to do best. It will send to everybody. This is how people were doing networking in those days. And it was okay because there were no bad guys. Or the bad guys have not woken up. They were still sleeping. Unlike now in our days, oh my goodness, in this generation, when you have even people just growing up trying to become something as Yahoo Yahoo, you can see they become Yahoo Yahoo from the womb. So everybody wants to make money. Everybody becomes bad just because of the environment. So you cannot afford to be using a Hub, guys, in this generation. So that is why we now decide to say, okay, or those who decide to say, we need to bring up another intelligent device that can, if the message is meant for us, Uche, it goes to Uche directly. If it's meant for Fasting, it goes to Fasting directly. If it's meant for Pedro, it goes to Pedro directly. Why should he be forwarding it to everybody? So they came up with a bridge. A bridge, if you remember in that class, a bridge is a smart device, just like it has small ports, few ports. It has just 2 ports. Some said 4. The one in Packet Tracer has only 2. That's why I didn't pick it to demonstrate, because there will be no way for me to show you guys how it sends to everybody. So I decided to use a switch. All right. Let's get rid of this Hub, guys. We have seen the lights. We've seen the lights. Let's get rid of Hub. Hub, bye-bye. Bye-bye. I'm going to bring in a switch. Bring in a switch. The same set of computers. The same set of people. So now we have replaced the Hub with a switch. Now we want to test for connectivity. But before we test for connectivity, I need to show you that MAC address table of a switch. Don't bother when we start configuring the router and switch, you will come to that level also. I'm going to go into the switch right now. I'm going to click the switch, come to command line, and just go to this is what we call command line. Show MAC address table. I'm telling the switch, show me what you got. Show me all the people you have recorded. The switch has not recorded anything. Look at what he got. It's supposed to record somebody's MAC address, the VLAN it belongs to, some other information, the port number. These are the ones we're particular about. Your MAC address, your port number. Your MAC address, your port number. So the switch is supposed to map MAC addresses to port number. What do I mean by that? Where are you plugged? If you take a look at that switch, it has multiple ports. It has multiple ports. Fast Ethernet 0/1, Fast Ethernet 0/2, Fast Ethernet 0/3, Fast Ethernet 0/4. So some people are plugged on port 1, some on port 2, some on port 3, some on port 4. The switch needs to know you by your MAC address and map it to the port where you're connected to. That is when it can make its intelligent decision. My ladies and gentlemen, at the initial stage, take note of this. The switch will also behave like a hub. Because right now, if I send message to Uche now, or Faustin or Pedro, the switch does not know where they are. See the MAC address table again. It doesn't know where they are. It's empty. So the switch needs to build this MAC address table, guys. And take notes of this. How does the switch build a MAC address table? It is only when you send an information, then the switch will now open that frame and say, oh, now you are the one that is on that port by reading your source MAC address and put you in the MAC address table and lock you down with that to that port. Take note, when you send, not when you receive. When you send the message, the switch knows that you are the one that is there. How? It opens the layer 2 message, the frame header, and sees your MAC address and puts it in the MAC address table. When the person replies back to you, the switch was okay. Is this guy that's on the other side? That is how the switch keeps on building its MAC address table. But guess what? As long as the switch has not built the MAC address table, it's going to behave like a hub. And that is why when the hackers want to hack into a switch network, or they want to create trouble on a switch network, they will flood the switch with enough messages that the MAC address table will be filled up, and the switch will just get angry and say, I'm not even learning any MAC address again. Then guess what? Any message he gets at that point in time, it will just be forwarding it to everybody because it's overwhelmed. We just send the thing to, it's like I'm overfeeding you. You don't believe food, I'm still feeding you, I'm still feeding you, I'm still feeding you. So the bad guys know how to overwhelm this, even though we have a means to stop that. So the switch will just get angry and start behaving like a hub. And any message is just be forwarding to everybody. Any message is just be forwarding to everybody. So you know that we still have a situation here. Even though the switch is a smart device, it can help us to manage our traffic, send, receive, and send to somebody and all of that. At the beginning, it will operate like a hub. Let me prove that to you guys. Same thing we did before. I want to send a message to Uche. Same thing. Uche is .2. So I will generate a traffic. Now there are two envelopes there. You need to ignore one of the envelopes because I'm going to talk about it later in another class. I think my app table has cleared up. Yes, my app table has cleared up. So just ignore the first envelope. I will talk about it in another class. I was just deliberating with myself yesterday. Do I talk about that one first or talk about this one first? Since that one is done, it's another chapter, done. It is called Address Resolution Protocol. I decided to take care of this today. So watch what the switch will do. What the switch will do. When I teach you guys the Address Resolution Protocol, you understand the reason for two envelopes. But let's watch what the switch will do. The message goes to the switch. Ignore this first message. The switch replicates it, send it to everybody. Somebody replies back with the switch, to the switch. It goes back to the computer. Now watch you. This is the one where I'm interested in. The message, this is the real message now. The real ping, because if I open that packet, I should have opened it from the source. You see that it is ICMP. Then the switch Oh, let me see. This thing has messed up my calculation. Okay, I will show you again. I'm going to do something again. And I will show you why that happened. MAC address table has been built. 2 people are already here. You see something here. I am on port 1, Uchi is on port 3. But I'm trying to show you something. Let me clear this thing again. Clear MAC address table. As if the switch has not built anything. I will show you. I will explain to you why that happens when we enter another class. That particular address resolution protocol class. Let me do that again. I know. Okay, so I have only one envelope. Now, the switch does not have Uchi's MAC address in its MAC address table. You see what the switch will do right now. The message will go to the switch. Because the switch doesn't know where Uchi is relocated, it's going to forward, what's going on here? Packages are done, they mess up me out today. Oh. Let me see. Did I clear that table? Yeah, I did. Let me reload. Just a minute, guys. Let me reload this switch. We're going to get at our destination. You'll see that the switch at the initial stage will do the same thing like a hop. But after that, once it has learned where you are located, it will now be behaving like a regular switch. Let me reload. Just a few minutes. This will be back. Just a minute, guys. It's still delaying now. Thank you. You there? Okay, let me go to read mode. I know why it's delayed. So let me see again. Show MAC address table. Okay, it's clear. So let me see. So let's do this again, guys. If what I'm trying to demonstrate is not working without talking about the app, then I have to teach you guys how to do that. Okay, it's ended. The entry list. Let me pick to build up that entry. Thank you. When I teach you guys the address resolution protocol, you understand what I'm trying to do here. Why we're having the 2 envelopes. So I want to clear the MAC address table here because it should have populated now. Yeah, I don't want it for now. Clear. Hold on. Okay. I just wanted to separate those topics. I think we are good to go now. Let's just finish. Why this thing is showing you red and then turning green later, you are going to find out when we come to router and switch configuration. I think I'm good to go. No. That's not what I want. Just bear with me, guys. Just bear with me. Okay, I see what something is happening here. You know what? Let me just teach you guys this hub thing. Let me teach you how. That if that is going to be messing up my explanation, so maybe we should just do the app. Then that won't take time. It won't take time. So what I want to explain now, if it doesn't work now, then I will just talk about the app, and then we can do this. So let me go to simulation mode. Simulation mode. I want to talk to Uche. Uche is on. It's 1 and 2. Okay, I got one envelope. So I've cleared the MAC address table of the switch, meaning it doesn't know where Uche is, ideally. So all things being equal now, the switch will get the message. It will replicate. This is the normal thing, guys. Then when Uche replies back, so when I send first, it will record my MAC address and put the MAC address table. When Uche reply, it will record, it gets Uche's MAC address and put it in MAC address table. That is the way the switch operates. That's what I'm trying to demonstrate. Now, if I want to send that message again, so now let's check the MAC address table and see whether we are there now. Show MAC address table. Look at me here. Look at Uche here. So the switch knows me. This is me here. And this is the port where I am plugged. The switch knows this is Uche here. And this is where Uche is plugged. So this thing is already in the MAC address table now. So subsequent information between me and Uche, there will be no problem. The switch will just send the message directly to where it's supposed to go to. So if I do that again now, you see what will happen. If I open that package now or that envelope, you see that source MAC address, destination MAC address, everything is there. Source IP address, destination IP address, everything is there. Not a problem. That has been taken care of. The switch also know where the Uche is located. So the message goes to the switch. Then the switch will look at the destination MAC address. If I click this now, you see it's the switch is all about layer 2. It does not have any business with layer 3. It's coming in through a particular port on the switch. That's another thing I need to point to you guys. Don't forget, I am on port 1. What's the name? Uche is on port 3. So this thing is coming in through port 1. It's going out to port 3. So whose source MAC address? Look at my MAC address here. Destination MAC address. And already the switch will just check his MAC address table. Okay, who is on that port 3? Is this guy. Okay, it will just put it to port 3. So let's see what will happen. Now, it goes to Uche. The switch did not replicate it this time around. Why didn't you replicate it? Because you know where Uche is located. And then Uche replies back, and then the switch sends it back to me, and that's the end of that conversation. But let's try Faustin or Pedro. They are not in the MAC address table. The switch will do exactly the same thing they did for Uche. So at the initial stage, your switch will work like hell, but once you populate that table, you know that it now begins to make informed decisions. So let's check. Let's try 1.3. Don't know who was 1.3. I think it's okay. Let's just confirm now. I think it's Pedro. Pedro should be 1.3. IP config. Yeah, Pedro is 1.3. Look at Pedro's IP address here. So what if I want to talk to Pedro? I will ping Pedro. I'll go to simulation mode, generate a packet. It's going to Pedro, don't forget. It goes to the switch. The switch doesn't know where Pedro is located. It replicates it and sends to everybody. After that, Pedro replies. Then it goes back to Roland. And that's the end of that conversation. Subsequent conversation, the switch knows where Pedro is located. If we go to the MAC address table right now, we're going to see that Pedro has also been added to the MAC address table. Pedro is on port 2. Same here. This is MAC address. So, subsequent conversation, the switch does not have a problem. It knows where Pedro is located. Did you see that? It goes directly to Pedro. Pedro replies. It goes back to Roland. That is how the switch operates, guys. So at the initial stage, the switch will behave like a hub. But once it's done learning the MAC addresses and the port numbers, mapping them, put them in the MAC address table, is different from a hub. It's no longer, it doesn't behave like a hub again. This is what I need you guys to understand. The switch uses MAC address table to make decision. You need to know how it builds the MAC address table. It's when you send from the source or when somebody reply. That's how it builds the MAC address table. And then once the MAC address table is fully built, it begins to make an informed decision. That is what I wanted to demonstrate to you guys today. So I'm going to pause the video here and then give room for question. Then we can start. If I not pause,